Okay, here is another question it's an actual test question from my class based on forces. So I have a frictionless car released from rest and has a fan pushes with a force of 1.3 newtons. So when when you're reading this, it's really a good idea to just go ahead and make a little picture. Here's my car. Here's my fan, F, and this is one dimension, so I'm not going to write this as a vector. We'll call this F1 equals 1.3 newtons. And M1 is equal to 0.333 kilograms. So you see, as I'm reading the problem, I'm writing down and drawing things to get kind of a picture in my mind of what's going on. Now I have a second car right there, and it has a mass of M2 equals 0.25 kilograms. And you'll notice also I went and converted this in my head to kilograms. I don't know that I need that, but in general it's going to be easier to work with things in kilograms rather than grams. So it has the same fan pushing on it. F1 is 1.3 newtons. Suppose I want the two cars to go 2 meters and get there at the same time. So that means that they're going to have the same acceleration. And I'm going to add a second fan here, F2, so that they have the same acceleration. So the question is, what magnitude of force should the second be? Okay, second fan be. So let's draw this up here. Let's look at fan 1, car 1. So in the x direction, I have F net equals F1 equals M1 A1. That's all I have. Okay, and I know that force, I know that mass. I could actually find the acceleration if you want to. So let's say A1 is going to be F1 over M1. I just solved for A1. Now for car 2, F net is going to be, there's two forces, F1 plus F2. Yeah. Equals M2 A1. I want to have the exact same acceleration. So I know the value of F1, I know the value of M2, and I know the value of A1. I want to solve for F2. So let's go ahead and put in A1 in here. So I get F1 plus F2 equals M2 times F1 over M1. And these are all numbers. If you put the numbers in now, that's cool, but you don't have to. Now I'm going to solve for F2. F2 equals M2 F1 over M1 minus F1. That's right. Okay. So let's put in our values. I get M2 was 0.25 over 0.333 times 1.3 minus 1.3. And you'll notice here something kind of important, that this is going to be a number less than 1, so this is going to be less than 1.3, so we're going to get a negative number. And in fact, that's going to make sense. But let's go ahead and calculate what that would be. Let's just put it in my calculator right here. Clear. Okay, so I need to calculate this number, so it's 0.25, 0.25, 1.3 times 0.33 divided by 1.3 minus, and I get negative 0.32 newtons. So what that means is, in order to make this one has a lower mass, if it had the same force and no extra fan, this one would win. This one would be too fast. So how do we slow that down? We need to have an extra force pushing in the backwards direction. So this fan is actually going to be pushing that way, which is fine. Okay. And there you go. That's the answer. Negative 0.32 newtons backwards.